And here's another sort of example you can do using de Moivre's theorem. So we're trying to solve this indicial equation. So z is a complex number. The power of 5 equals 2 minus j. So the first thing we do is just simply rearrange that to tell us that z equals 2 minus j to the power of 1/5. And we want to be able to use de Moivre's theorem for doing it, which means we're going to need our complex number in polar form. So if we change this into polar form, we've got 2 minus j. There's our Argand diagram. So we need this angle in here and the length. Well, the length's easy, it's just 2 squared plus 1 squared is 5, square root is 5. So the length is root 5, and the angle is tan inverse of negative a half, which, if we wheel out the good old trusty calculator, is tan inverse of negative 1/2 is negative 0.464. Okay, so we now have our number. So we're trying to say that z equals root 5 cis negative 0.464 all to the power of 1. And de Moivre's theorem tells us that we can do this by the power of the magnitude. So it's root 5 to the power of 1/5, cis the angle, negative 0.464 plus 2 pi k for all the loops, times 1/5, which is the same as divided by 5. And we're going to be interested in k being 0, 1, 2, 3, or 4. So we're in a fifth root, so we need 5 solutions, so we need 5 different versions. And then we just go through the same process. We just start with k equals 0 and work out the answers. So if k equals 0, z equals the fifth root of the square root of 5, so we work out that out. So the square root of 5 is something or other, and the fifth root of that, so to the power of 0.2 is a smart way of doing it, is 1.175. 1.175, and then it's the cosine of the angle. So with k equal to 0, that all disappears, and we end up with 0.464 divided by 5. So negative 0.464 divided by 5 is negative 0.0928. Negative 0.0928 plus j sine, same thing, negative 0.09. And there's no reason why you can't just leave it like that. If you want it in rectangular form, well, there sort of is in rectangular form, really, isn't it? There's a real bit and there's an imaginary bit, but you could solve the cosine and work out the numbers and come up with, I'll do it for this one, but you can do it for yourself for the other ones. So if we're dealing with that number there, we're going to go 1.175 times the cosine of that previous answer, gives us 1.17, which isn't surprising, such a small angle. And then for the sine one, we're going to end up with 1.175 times the sine of negative 0.0928. That's going to be very, very small, I'd imagine. Negative 0.11. So minus 0.11 j. So there's the imaginary number in a nice simple rectangular form. And if k equals 1, then z is going to be the same magnitude, because it's just that root 5 to the power of a fifth, which is going to count the same both times. And now we're going to be dealing with the cis of this thing with k equal to 1. So we have to work out what that value there is. It's going to be negative 0.464 plus 2 pi all over 5, which gives us 1.164. Yep. And if k equals 2, repeat process. Okay, so now we're dealing with k equal to 2, so we go through the same process and we come up with an answer. I'll do it for you. So negative 0.464 plus this time 4 pi, lost my pi button, there it goes, 4 pi, all divided by 5 is 2.420. 2.420. And if k equals 3, okay, now I'm just going to get lazy here. So basically each time we're adding on an extra 2 pi over 5. So if I just take my number and add 2 pi over 5, so plus 2 pi over 5 gives me 3.677, and when k equals 4, doing the same thing again, adding the same bit, we have 1.175, and just adding that same thing again, this time gives me 4.934. Okay, so there's my 4 answers. I've made the first one into nice simple rectangular form, but the other ones you can make into rectangular form as well by doing the same sort of thing. And if you were to stick them on the Argand diagram, the first one is 1.17, maybe about there, negative, so the first one solution will be about there. And then the other solutions will be equally spaced at the same radius, so they'll be around the same size circle, which I'm not very good at drawing, so they'll all be around that size, and they'll be evenly spaced around it, so there'll be 5 of them, so there'll be one up here somewhere. So, I haven't done a very good job of just evenly spacing 5, but they will be evenly spaced around the circle, and those angles will give you those even spacings.